In this video, we are going to look at graphs of exponential equations. And so we are going to build a table of values, and then we are going to plot it to see what that graph looks like. When you are making a table of values, I highly suggest that you make sure that you include both negative values to plug in as well as zero, as well as positive values. So I typically start with those 5, and then you're plugging them into your equation. So when I take a base of 4 and I raise it to the power of -2, keep in mind that negative exponents are going to flip your base over. So 4 to the -2 would be the same as 1 over 4 squared. So notice once it flips it over, the power is no longer negative. And so 1 over 4 squared would give me 1 over 16. So when x is -2, I have a point that's really close to that x-axis at 1 over 16. Okay, when x is -1, I take 4 raised to the power of -1. Again, the negative power is going to flip that and make it 1 over 4 to the positive 1, or simply 1/4. So when x is -1, my y is 1/4. And it's kind of hard with that small of graph to show those small values, but the main thing you see there is that they're increasing. Okay, so my next x value is 0, so 4 to the power of 0 is 1. So 0, 1 would be on my graph. And then when x is 1, 4 to the first gives me 4. So that would be the point 1, 4. And then finally, when x is 2, 4 squared would give me 16. So when x is 2, notice that's going to go off my graph. So if that's 10, 11, 12, 13, it's going to be somewhere up here, which is fine. Now, you'll notice as the points went to the right, they were increasing, and the further they went, the steeper they got. The other thing that should happen here is because you have a positive 4 as your base, you're never going to plug in a number that gives you a negative answer. So what we say there is that part of the graph follows the x-axis with a horizontal asymptote. It just technically gets closer and closer and closer to that x-axis. And so we describe this particular graph as an increasing graph because it is going up from left to right. And that is typically going to happen when you've got a base like this that is bigger than 1. Okay, now sometimes we get into some graphs that are going to have some graph shifting done. You can still build a table, but depending on the graph shifting that they have involved, you may not know ahead of time whether it really is increasing or decreasing because it really depends on how it got shifted. And so I still recommend starting with some negative values as well as 0 as well as some positives. And then if that doesn't give you a good enough understanding of what the graph looks like, you can certainly add more to the table at that point. So in this case, we have a base that is a fraction, 1/2. And we have a power that has the expression 3 minus x. So notice on this first one, let me just change colors so I don't blend in there. When I take my power of 3 and I subtract my x of -2, that 3 minus -2 is going to actually turn into a positive 5. So I end up with 1/2 to the positive 5 power. So on top, 1 to the 5th is 1. On bottom, 2 to the 5th will give me 32. So when x is -2, again, I'm very, very close to that axis at 1 over 32. Okay, when I plug in an x of -1, again, I take my base of 1/2, but the power says take 3 minus my x. So when I do 3 minus -1, that'll actually become a positive 4. So 1/2 raised to the 4th power becomes 1 over 16. So again, just slightly increasing there. When x is 0, and I take my base of a half and I raise it to the power of 3 minus my 0. That's the same as 1/2 to the third power, which would be 1/8. So again, we see the values are going up, but just very, very slightly. When x is 1, I take my base of a half and I'm going to raise it to the power of 3 minus 1, which will leave me with a power of 2. So 1/2 squared would give me 1/4. And again, it's so hard to show those little values. I look like I'm way more than a fourth, but you get the picture that they're still getting a little bit bigger. When x is 2, and I plug that in, I'm going to raise it to the power of 3 minus 2, so that'll leave me with 1/2 to the first, which is just a half. And again, that should really be right there, so these points should be. So they're going up. You still have what we call an asymptote right there. And if you want to, then I would just jump and do something like a bigger x, like 5. So when you have 1/2 to the power of 3 minus 5. So 3 minus 5, that leaves you with a 1/2 to the power of -2. And remember, we said negative powers flip your base. So 1/2 will become 2/1, and then once it flips it, the power's positive, so you get 4. So when x is 5, we get a point that's up here at 4. And so initially we may have not expected an increasing graph, but what happened is because on the graph shifting, that negative that they actually put in front of that x, that caused it. So again, if you'll just use the table to generate points, that's probably one of the best ways to be able to see what the correct graph of the function looks like.